But, you know, we know it's going to be bad because it has to be. Because it should be, if anything, lower in circuit, not higher.
Yeah, well, they fooled us in circuit because I went over those, I thought.
Look!
I think I went over those two resistors in circuit.
Look!
No.
How can that be?
It was just coating on the lead that was fooling us.
How come they both did it?
They both had the same coating on the leads. That's weird. I didn't think we could get fooled that bad. Huh. What? That is a trip.
Weird stuff.
Well, maybe we didn't find a problem.
Shoot. It just looked weird because they were, you know, both twos.
Yeah, we pulled these two resistors out of this board because we measured that they were 2 meg, we thought, and they're supposed to be 2.2 Ks. We thought we found our problem, but now he's got them all the way out of the board, and you can measure the wet ends of them. They're measuring normal, more or less. So we thought we were all done with this situation, and we still struggle on with this Tigersaurus. This Tigersaurus has a long history of overheating and oscillation, and it goes into oscillation on its own. There's also ways you can trigger the oscillation with real tiny little impulses. You can trigger it. I was just putting a cap across the power supply and it would trigger it. So one of Kurt's Tigersauruses, the 210A, has been bedeviling us for a long time with intermittent oscillation. Just when you think you got the whole thing all straight and everything, it goes into oscillation. It was real easy to trigger it, just putting a capacitor across the power supply, a small capacitor. That small impulse was enough to trigger the oscillation to start happening. And I tried things like trying to cut the... It's hard to cut out the feedback loop because the amp is going to have a lot more gain without the feedback. So I was kind of experimenting with trying to isolate or attenuate. Anyway, that all didn't work. That was just frustrating me because it's a circular path being a feedback loop. So what I ended up doing was going after why certain resistors were overheating on one side and not the other. I'm not sure if this is the one or not, but say this resistor was overheating and this one wasn't. We had that situation in a few resistors like that where they weren't evenly heating and some were overheating, even with the bulb in series with it, you know, having a light bulb in series, killing some of the power. So I decided to go around it a different way and go after that uneven heating and the voltage imbalance. And what we ended up doing, we worked our way back from the back towards the front. We ended up all the way back here isolating these two bases. So I had Kurt literally solder suck the boards and stand the leads up out of the board straight up so that it's not touching the edge of the board without pulling these transistors completely because they were, well, first I wanted the emitter still hooked up to make sure there wasn't any trouble there, but also I wanted these are in a case. They're in a metal heatsink. It's part of the case, so I didn't really want to pull them. It was kind of a hassle. So we isolated those two bases, and once we did that, the whole back side of the amp all started behaving real pretty. I mean, overheating resistors went away. They were all, everything was stock normal. Everything in this part of the amp just went normal after we took these bases off. So I figured it's got to be up here. The next thing we did was start going after looking into these a little better. These both have 9.1 volts at the Zerners. So the Zerners are working. Transistors are new, basically. I guess I have to go through and make sure that not one of them isn't in backwards and that they're the right numbers. But Kurt's pretty good at getting that stuff right. I'd be surprised if he screwed that up, but it's possible. You know, these are EBC, emitter-based collectors, so if you switch them around backwards, they're collector, base emitter, they'll still work to a degree. So there's possibilities like that, or one of the transistors might be bad. Kurt is on that right now. He's getting some new transistors he'll return with in a few days. So the way I left it, though, is we replaced these two resistors because they had been overheated and stuff. And we left the one ends hanging, unhooked from the differentials, just hanging in the air. And then I hooked, like, I think it was a 2K, some kind of resistor in between the two, just so these two circuits would work. So we're down basically to, a half dozen components, plus that resistor between them. And even at that point, we still had a pretty good voltage differential. They weren't doing the same voltage on both sides. The one was, Kurt's got all the numbers written down somewhere, but I think it was like 1.5 volt difference between these two. So something's obviously wrong in here. And then we're down to a half dozen components. So either the transistors are bad, or there's some kind of short on the PC board that I'm not seeing, or some kind of error on this PC board. This might have always been there since the sample was built. You know, he bought these used, he didn't build them. We've kind of been reconditioning these amps he buys. So he'll come back in a few days and we'll figure it out. We'll switch these transistors out and see if that cures it all. But like I said, I got these two unhooked from the circuit and just a resistor between them. So we're down to a pretty small number of components at this point. I'm pretty confident once we get this voltage difference fixed, the whole amp will be pretty much fixed. Because we fixed a lot of little things before. We swapped outputs and stuff. Some marginal outputs, leaky outputs and stuff that we got rid of. This amp should be in tip-top shape once we get it going. Plus he replaced all the capacitors, all the little capacitors in this circuit board. And a good deal of resistors too. So hopefully we'll get this sorted out.